And now we're going to review implicit differentiation, and we're going to review it specifically for problems we're going to need for dynamics. And now one thing to mention here, we're going to call x dot is going to be the derivative of x with respect to t. And we're going to call x double dot the second derivative of x with respect to t. Y dot is going to be dy dt. Y double dot is the second derivative of y with respect to t, like this. So keep that. We're going to use this notation for these. Now, before we do implicit differentiation, let's just get some ideas first. So let's say we have a function like this. Let's say we have a function y equals 3t squared cubed. And we want to find dy dt. Once again, that's the same as y dot. So let's do that. So we'll do y, take the derivative of y, call that y dot. Then over here, we're going to take the derivative. We'll have to use the chain rule. 3 plus t squared times the derivative of the inside, which is 2t. So remember, we used the chain rule. We brought this down, the derivative of this. Then we had to do the derivative of the inside over here and did that. So now let's look at this example. Y equal x cubed, where x is a function of t. And once again, we're going to find dy dt, or like I said, let me call it y dot. Let's do that. So solution, so we do y dot just like before. Now, this is similar to the previous problem where we had 3 plus t squared cubed. Now we have some function of t, but this time we don't know what that function is. We're going to do almost the same thing that we did before. So just like before, we're going to take 3x, just like we did before. Took 3 times over here, and then that's going to be squared, huh? Then we have to use the chain rule. We have to take the derivative of this. But we don't know what this function is. So we would like to take the derivative of this function that this represents with respect to a, but we don't know what it is, so we can't actually explicitly do it. So we have to do it implicitly. We just say, okay, we want the derivative of that function. And so write it like that. And so that's kind of telling us we want the derivative of this function of t, but we don't know what it is. So we put there, see, before we knew what that function was and we could write it explicitly. Now we have to just do it implicitly. Again, we do that because x is a function of t. If this was just the usual x, we wouldn't have to do that. So keep that in mind. Let's take a look at some other problems. Let's do this one here. Find y prime, where let's say this time is, let's just say we have x, y plus x to the 1/2 y cubed equals 7. Again, if you recall, when we do this, we don't have to solve for y first. That's one thing that is nice about implicit differentiation. We don't have to solve for y first. We probably should say to start here, note x, y are functions of t. So again, usually what we do, we'll just go across this whole equation and take derivatives. So over here, take the derivative of the first times the second plus the first times the derivative of the second. Once again, we don't know what these functions of t are, so all we have to do is just put x dot. And remember, if we just have an x here, we take the derivative just x dot. We don't really have to do anything else. So we took the derivative of first times the second plus the first times derivative of the second. Now let's go over here, do the product rule again. So now here it's a little bit more complicated. We have to do the 1/2. Again, derivative of the first 1/2 x to the minus 1/2, as we usually do. But again, we want to use the chain rule because this was to a power. So we have to take the derivative of this, but we don't know what that function is. So we just have to put x dot. Then that's times y cubed. So that's a derivative of the first times the second, then plus the first times the derivative of the second. So we're going to have, again, it'll be the chain rule again, 3y squared times the derivative of the inside. Again, we have to use the chain rule, take the derivative of this, but we don't know what that function is. So we're going to just put y dot here, like this. So when we work to this, derivative of first times the second plus the first times derivative of the second. Then we go to the right-hand side, the derivative of that with respect to t is going to be just 0. Now, in this case here, we want to solve for y dot, so we'll have to maybe rearrange things a little bit here. So let's get everything that doesn't have y dot on the right-hand side. So let me move this over to the right-hand side, negative x dot y. Let me move this to the right-hand side, minus, I'm going to put this in the denominator. That'll be y, and then I'm going to just make that square root of x. So all I did was, and I forgot my 2. So then over here, all I did was bring this into the denominator because it was negative, and because the power was negative, made that 2 x dot, and then brought everything to the right-hand side. And let's see, and that's everything. It doesn't have y dot, so let me keep everything with y dot on the left. Bring that 3 out front. like that. So again, I just brought this down and brought this over to here. And now we want to solve for y dot. So again, usually you don't have to put all these steps in, but I'm going to just factor that out. So I just factor out the y dot. Now divide both sides by this. I'm going to have y equals negative xy, negative, excuse me, that was the dot, x dot by 2x divided by x plus 3, x to the 1/2, y squared, like that. So let's do one more example, or at least one more. We'll see how this goes. So let's say you have an equation. This might be typical what you might have. Let's say you have equation given by this, and you have maybe theta. I call this theta cos theta, like this. And let's find, and let me find, this time let's find r dot and the second derivative, r double dot. This might be a type of equation you might be working with in dynamics. So let's take a look at this. So again, the derivative, once again, r and theta are functions of t. And so let's take the derivative. So again, on the left, this would be r dot. And again, we have a product here, derivative the first times the second. Excuse me, there shouldn't be anything up there. Just like that. Let me write that a little bit neater. And let's scratch that out. So r dot is going to be derivative of the first times the second plus the first times the derivative of the second. Remember, do the derivative, that's going to be negative sign. And then we have to use a chain rule. So we have to take the derivative of this. Again, it's a function t. We don't know what that function is. So we just have to put theta dot like that. And let me just rearrange this a little bit better. Theta dot, cos theta. And let me put the negative in front here. Theta dot, sine theta, like that. It's a little bit messy. Apologize for the mess. So now let's take the next derivative. Second derivative here, that'll be r double dot. And now we have a product here. Once again, derivative of the first is going to be theta double dot times the second plus the first times the derivative of the second. That's going to be negative sine theta. We have to use the chain rule. So it's going to be theta dot. So this is the derivative of that. Let's just double check. Derivative of first times the second plus the first times the derivative of the second. Then over here, now we have a product of three things. So we're going to have to do it at this will have three parts. It'll be derivative of first times the second and the third, like that. I'm going to have to go down to the next line. So we took the derivative of first times second, third. Now it'll be next will be the first times the derivative of the second times the third. Then finally, it'll be the first times the second times the derivative of the third. Remember, that's going to be minus cos theta. And we have to use a chain rule again. So that'll be theta dot, like that. And again, you could possibly make these all look a bit nicer. We could probably combine a few things. Let me just see if it's possible to do that. So let's see. So here we have theta double dot, cos theta. Over here, this is going to be theta dot squared. And over here, this will be theta dot squared. And they're both theta dot squared times sine. So we'll have two of those. So negative 2 theta dot squared sine theta. Then over here, we have minus theta double dot sine theta. I'm just copying this down basically. Then over here, this will be negative. That's going to end up being plus theta. We can multiply these two together. Theta dot squared cos theta. So there you have it. Let me maybe do just one more. Let's do this one. Let's say we have an r squared here. Don't let that throw you off. And so let's say we have a 3 theta plus 4 sine theta. Let's say we have something like this. R and theta are functions of t. Find r dot and r double dot. Let's do that. So once again, let's take the derivative of this. So on the left-hand side, now notice, now this time we have it squared, so we're not going to be able to just put r dot. See, before we just had an r over there, then we could just make that r dot. Then when we took the next derivative to make r double dot, but we have a square here, so we have to use a chain rule again. So that'll be 2r, then times the derivative of this function, which we don't know what it is, so we'll just put r dot like that. So again, use a chain rule 2r, then times the derivative of that function gives us this. And then just go across. This would be 3 theta dot plus 4. Again, the derivative of this is going to be negative cos theta. We have to use a chain rule, so it's going to be theta dot. And now we could clean this up a little bit more. Let me just rearrange this a little bit. 3 theta minus 4. I don't know, let me put the theta dot in front here. Cos theta, just to make it look a little nicer. Now, at this point, you could solve for r dot and then, do the next derivative that way, but it's probably a little bit easier just to continue the way we're doing. So we take the next derivative, do the derivative again. We have a product over here. So it'll be, so you can consider like this times this. So let's take the derivative of this, the product rule, derivative of that, the first times the second, plus the first times the derivative of the second, like that. So that takes care of the left-hand side, took the product, derivative first times the second, plus the first times derivative of the second. Then on the right-hand side, this is going to be 3 theta dot. Then once again, over here, we have a product. So we'll consider that this kind of being the product. So derivative of the first, which would be 4 theta double dot times the second. Then it'll be the first times the derivative of the second. So cosine goes to sine. We have to use the chain rule. Derivative of this, that's going to be theta dot like that. So then usually when you get to this point, you'll be given or otherwise be able to find what theta dot, theta double dot, r double dot, etc., what some of these values are. Then often you can just substitute these and then solve for that. But that's the mechanics of doing implicit differentiation, particularly with time, if everything's a function of time.